Exercise 10.4. Second question. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of the other chord. So, a circle with center O and two chords which are equal, AB and CDB, two chords which are equal, and join P and O. They draw OM perpendicular to CD and OL perpendicular to AB. We have to prove that the segments, that means we have to prove that AP is equal to CP and DP is equal to PB. We have to prove that the segments are equal. That means AP is equal to CP and PD is equal to PB. For this, what you have to do is, we are using the congruence itself. We have to consider these two triangles. Triangle PMO and triangle PLO. Triangle PMO and triangle PLO. So, what are the equal sides? What is given? What we have constructed is angle M is equal to angle L is equal to 90 degree. Angle M is equal to angle L is equal to 90 degree by construction. Then any common side? Yes, PO. PO is equal to PO common. PO is equal to PO common, which is the other side. So we got one right angle and one side. That the side is the hypotenuse because that is the side opposite to 90 degree. What about OM and OL? What about OM and OL? They are equal. Why? Why OM is equal to OL? Because what is the reason? Equal chords are equidistant from the center. Equal chords are equidistant from the center. So, OM is equal to OL. Chords which are equal, equidistant from the center, or equal chords are equidistant from the center. Equal chords are equidistant from the center. So, what we can say, triangle OMP is congruent to triangle OLP using which criterion? 90 degree, one side and hypotenuse. So, what is the criterion? RHS criterion. Using RHS criterion. So, if these two are congruent, we can say that this PM is equal to PL. Why? Using CPCT. PM is equal to PL using CPCT. We can mark this as equation 1. So, next what we are going to consider is, what about CM and AL? What about CM and AL? Is it equal? Yes, they are equal. Why? Perpendicular from the center to a chord bisect the chord. So, these two bisects means CM is equal to MD and AL is equal to LB. But what is given? Both these chords are equal. So, half of these two are equal. So, what we can write as CM is equal to PL. What is the reason? Perpendicular from the center to a chord bisect the chord and both the chords are equal. So, perpendicular from the center to a chord bisect the chord, bisected, and AB is equal to CD. So what we got is CM is equal to AL. Then we can write CM as CP plus PM and AL as AP plus PL. CM we can write as CP plus PM is equal to AP plus PL. But what about PM and PL? Equal using 1. We can cut these two because these two are equal using 1. This implies that CP is equal to AP, equation 2. So we got the first result. CP is equal to AP. Then what you have to prove? We have to prove that PD is equal to PB. For this, what you have to do is, we have to take AB is equal to CD. It's already given. AB is equal to CD is given. Then how can you split AB? AB we can split as AP plus PB. AP plus PB is equal to, same way this CD you can split as CP plus PD is equal to CP plus PD. But what about AP and CP? Equal using 2. We can cut these two using 2. So what this gives? PB is equal to PD. This is the last result. So what is given in this question? A circle and 2 equal chords are given. We have to prove that both the segments are equal. That means we have to prove that AP is equal to CP and PD is equal to PB. For that, we have joined P and O. Then we have drawn OM and OL perpendiculars. Then we proved both these triangles are congruent. From that we got PM is equal to PL. Then we have taken CM is equal to AL because these are the perpendicular from center to the chord, bisect the chord, and both the chords are equal. So we can take CM is equal to AL. Then we have split it. From that we got CP is equal to AP. Then last one what we have taken is, we have taken the total length AB and CD. We have written AB as AP plus PB and CD as CP plus PD. Then since AP and CP are equal, we are getting PB is equal to PD. Next question. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angles with the chords. Same type of question. A circle is given, two equal chords are given, AB and CD are two equal chords. What we have to prove is the line joining the point of intersection to the center makes equal angles with the chords. The line joining from the point of intersection to the center make equal angles with the chords. That means we have to prove that angle MPO is equal to angle LPO. For this we are using the congruence itself. Consider triangle PMO and triangle PLO, triangle PMO and triangle PLO. Same steps. What is common? PO is equal to PO common. Angle M is equal to angle L is equal to 90 degree by construction. Next is OM is equal to OL because equal chords are equidistant from the center. Equal chords are equidistant from the center. So what we can say from this? we can say that both these triangles are congruent using RHS criterion. So, triangle PMO is congruent to triangle PLO using RHS criterion. If these two are congruent, what we can say? These two angles are equal using CPCT. Angle MPO is equal to angle LPO using CPCT. So, this is the final answer. We are proving the angle made by the line joining from the point of intersection to the center with the chords are equal. So, what we got is angle PMO is equal to angle LPO using CPCT. Then the first question, two circles of radii 5 cm and 3 cm intersect at 2 points and the distance between their centers is 4 cm. Find the length of the common chord. I have drawn the figure. PQ is a common chord and C1 and C2 are the centers. So, the first radius is 5. So, this is 5 cm. Second radius from the center. So, this is 3 cm. Distance between these two centers are given as 4 cm. What we have to prove? Find the length of the common chord. We have to find the length of the common chord. See, which is the common chord here? PQ is the common chord. We have to find the length of PQ. For that, what we are going to prove is C1, C2. What we are going to prove is C1, C2 is a perpendicular from the center C1 to the chord PQ. That is what we have to prove. We have to prove that C1, C2 is a perpendicular from the center to the chord PQ. So, if it is like that, what we are getting is it bisect. If it bisect, we can take the double of this. So, what we are applying here is using the Pythagoras theorem. Pythagoras theorem, what is 5 square? 25. 4 square plus 3 square. 16 plus 9 again equal to 25. So, what we can say? So, what we can say is PC1 square is equal to C1 C2 square plus PC2 square. That means the square of the hypotenuse is equal to the sum of squares of the other two sides. If Pythagoras theorem holds, we can say, what we can say? One angle is 90 degree and that should be the angle opposite to the longest side. So, this means that Pythagoras theorem holds. If Pythagoras theorem holds, we can say one angle is 90 degree, that should be the angle opposite to the longest side. If here, which is the side, longest side? Longest side is 5 cm. So, the opposite to that, longest side is this, opposite to this is 90 degree. So, we can write this as, this implies that angle C1 C2P is equal to, angle C1 C2P is equal to 90 degree. If this is 90 degree, what we can say? This is a perpendicular from center to the chord PQ. This means that C1 C2 is a perpendicular from the chord AB, the chord PQ. So, therefore, it bisects. Therefore, PQ bisects. Therefore, what is the length of PQ? Therefore, PQ is equal to 2 times 3, which is equal to 6 centimeter. PQ is equal to 2 times 3, which is equal to 6 centimeter.